So I shall be start today. I'm going to start module 2. Okay. So before going to module 2, there is one very small topic which was left in module 1. So I'll be saying that first, and then I will start module 2. So though I have already discussed this, but just again. Backbone networks. What is a backbone network? Basically, like you have seen in the campus that when you are that we have LANs in different hostels, and we also have a backbone network laid down in the entire campus, right? To which all the LANs from the hostels are interconnected. So backbone network, when I say, it's a high capacity LAN which interconnects smaller LANs. Right? So backbone networks there can be two type of backbone network. Backbone network can be classified based on there is a bus backbone and there is a star backbone. This is also known as a collapsed backbone network. What is the difference? You must understand that in a backbone network, a high capacity LAN interconnects smaller LAN. Generally, what mistake the student does, that they interconnect the system directly to the LAN, to the backbone network. So in a bus backbone, the topology is bus, okay, and the star backbone, the topology is star. So in a bus backbone like this, it interconnects smaller LANs, right? In a star topology, it's a hub and it connects LAN 1, LAN 2, station 1, station 2. So station should not be directly connected to the backbone network. This is a backbone. Right. So why it is called as a collapsed backbone? Because the signal gets collapsed in the switch itself. That is why it is also known as collapsed backbone network. Right. So bus backbone topology is bus star. So this type of bus where you can use this bus backbone like in our campus to interconnect the smaller hostels. So application you can say, right, and a star backbone is used to in the office buildings and other things, right, where you have multiple smaller LANs to be interconnected to a backbone, right. Now coming to the second module, which is based on internetworking operations. So we will first see that what is internetworking and what are their requirements, what are the architectural approaches, Okay. So internetworking is like when we were discussing so far about the bridges. Whenever we were talking about bridges were able to interconnect only similar lanes, right? But when you are talking about internetworking, means when you are moving the data from one network to the another network, it is not necessary that all the network will be alike, right? That they may different. So you need a device which can interconnect dissimilar networks or dissimilar lanes, which can transmit data or receive data on dissimilar networks. So we have routers. Router works on the three layers of the OSI model, that is physical layer, data link layer, and the network layer. Right? It uses IP addresses uh, for forwarding the datagrams. Right? Uh, so basically, to see that basically internet networking operation, okay, we first know about that we have adopted an internet protocol IPv4 or IPv6. So before adopting a protocol, right, what are the things one should like think that a protocol should have, right? So what are the essential requirement of a protocol to work in an internet to an environment like internet, right? So so these are some protocols functions that we will first do quickly, and then we will move. So so there are some small set of functions that form basis of all the protocols. Uh, it is not necessary that all the protocols will have the same functions, because it reduces the duplication of effort, may have same type of functions in the protocol at different labels. Just like I told you that why OSI is not that much useful, because there was a repetition of duplication of efforts. Because I told you a difference in TCP/IP and OSI, that OSI is mm, a ready-made shirt, right? That a person will try, it may fit, it may not fit. Okay. While on the other end, a TCP/IP model is a uh, shirt stitched by a tailor. So it will be well fitted. What is the difference? Like in TCP/IP was well established earlier, and it was tested for Department of Defense. Okay, in US, they were doing it for advanced research project ARPANET, that you had done it in the previous semester. So it was all well established and it was useful. And then what in case of OSI provided a generalized framework, right? That these are the layers, they have divided the 7 layers, and they specified the function of each layer, and they said that any protocol which provides a similar kind of services can be put into it, right, in that particular block. So there are though they specified that there should not be any overlapping, but there will be overlapping. So all protocols should not have the similar functionalities, right? So what are the protocol functions? Encapsulation. Can you say what do you mean by the encapsulation? You know that the data is usually transferred in blocks. We say that in protocol data unit, each PDU contains data and control information. So these category of control, so adding a control information to the data is called as an encapsulation. So what is there in the control information? You know that there will be addresses of source address, destination address, CRC, protocol information, that which protocol is being used, okay, and how will it be implemented, or then there are some other headers, right? Uh, so so the main thing is that encapsulation means adding control information to the data. Now, can you say what do you mean by fragmentation and reassembly? In OSI we say segmentation, in TCP/IP we say fragmentation, right? That is the difference. Or why the fragmentation is necessary? What are the advantages and disadvantages of fragmentation? And where exactly the fragmentation should be done? Can you say? Anyone? See, I just now told you that now the data will be moving from one network. This is network 1. There will be a router. There will be another network, right? These two networks may be totally different, right? And their maximum packet size limit may also be different. That is called as an MTU size, maximum transmittable unit. Okay, so if this maximum transmittable unit is different, each network has a different maximum transmittable unit. So once the packet, suppose here this network has 1200 bytes, this network has suppose 1500 bytes. Then a packet arriving at this router will be simply forwarded on this network because its maximum packet size limit is more than the packet size limit of network 1. But if suppose if it is only 500 bytes, then in that case this router shall be responsible for fragmenting this data into smaller fragments, right? This data will be fragmented into small number of fragments. So maybe depending on the decision taken by the router, it may construct more than one fragment, right? So it will divide this 1200 bytes of data and there will be some header information. So it will make suppose 400, 400, 400, and this header will be copied in all the fragments, right? So if you go right, if you go and keep on fragmenting the packet further, like how long, I mean how much you should do the fragment, how many blocks you should create, smaller blocks. See, there are some advantages and disadvantages of both the things, right? Because the lower level protocols may need to break data up to into smaller blocks, because the communication network may only accept blocks of up to certain size, as I said, maximum transmittable unit. So ATM it is 53 octets, Ethernet it is 1526 octets. So see, first let us see the advantage of reducing the means like having more number of fragments, that the processing time at the router will be minimal. Okay, because if you are processing a larger packet, larger PDU, or you are processing a smaller PDU, that the time difference will be there, right? So it will be, if you are processing a smaller PDU, the time will be less, processing time will be less at the router. Second, you will be having more efficient error control because you are applying CRC on a limited number of bytes, right? Smaller, if suppose something happens to, if a particular fragment is not successfully transmitted, only a smaller set of data needs to be retransmitted. So it is good situation, okay, and moreover it is fairer also, because it stops stations to monopolizing the medium. Suppose if a station with a very large PDU will block the network, because it is, if that particular station is using the network, all the stations with smaller data will not be allowed to send until the medium becomes free. So in that sense, that station with larger frame size can occupy the medium for a long period of time, and during that period the smaller stations will not be given any opportunity to transmit. So in that way, and it requires smaller buffers at the routers. Okay, so in that way, if you see, all are good. But what is the disadvantage of fragmentation? Can you say, anyone? Anyone? What can you say the disadvantage?
फ्रेम लॉस.
फ्रेम लॉस क्यों बोल रहे हो? मतलब डिसएडवांटेज क्या हुआ? यू जस्ट you just see that I have made 3 smaller fragments of 400 bytes each, right? But every time I am making a fragment, this header information is being copied. So this is what? An overhead. Because if you reduce the fragment size to a very low value, what will happen? There will be more header than the actual data, right? So are you following that as many numbers of fragments you are creating, the overhead is increasing, because this header information needs to be copied in all such fragments. So this will keep on increasing the overhead, right? Any other difficulty? So if you are going for smaller blocks, there will be larger overhead, and in many cases, like that the arrival of the PDU generates interrupt. जैसे आप क्या करते हो, whenever you perform any banking transaction, right? Whenever you operate your ATM or whenever you operate your online banking system, what happens? You get an interrupt, right? You get a message. Similarly, in the network, with many times, like for any PDU arrival, there will be an interrupt. So more number of PDUs means more smaller blocks means more number of interrupts, right? So as compared to, even though the processing time of each fragment is less, but the header information will be same now in all the fragments. So ultimately it will be more time consuming. So that is what the advantage and disadvantage of fragmentation. Can you say about reassembly? What do you mean by the reassembly?
डेस्टिनेशन राउटर पे सारे फ्रैगमेंट्स को जोड़ना.
Correct. So if I say that, suppose if I am using a connectionless approach, right? Because if your approach is connection oriented, right? If you are using a connection oriented approach, there is no issue, because all the fragments will be passing through the same channel, right? Once the connection is established, the data will be passed over that. So there is less chances that the data will be lost, or they will be delivered out of sequence. But at the moment when I talk about connectionless approach, where especially a datagram approach, if I say, which is used by the internet protocol, datagram approach. What is a datagram approach? That a packet or a fragment can move in the network. Suppose you are sending it from source to destination, packet can move from anywhere in the network in order to reach the destination. Right? It can choose any path, right, to reach the destination. And moreover, it is unreliable. So suppose if you have fragmented one frame here, you have fragmented one PDU, so the blocks of that, all the blocks may not choose the same path. All the blocks may choose different path, right? All the blocks may choose different paths, and may result in out of order at the destination, right? So if they are not in order, and since it is connectionless approach, all the blocks may not reach at the same time at the destination. There will be a delay. Okay, there will be a variable delay among the different blocks, right? So that will make the situation more complex, because all the packets should be in time, all the fragments should reach in time, and then the ordering should be done. Then only the delivery will be there. No, otherwise how will you deliver the data, right? Once you connect all the fragments, then only you will connect it. No, so it is just like a game. Generally, children used to play, like there will be blocks. So one complete image you break into smaller blocks, right? And then you search, and at the destination you search all the blocks, that which block will be put to be connected where. So then only your data frame will be completed, right? So can anyone say that if I am talking about connectionless approach, uh, where exactly the reassembly should be performed? The reassembly can be performed at the destination or at some intermediate device. Huh? Where exactly the reassembly should be performed?
Destination.
Why not intermediate device? Intermediate device समझ रहे हो ना आप? Intermediate device means there will be one router here somewhere. Uh, why can't you perform at the router intermediate device? What is the issue?
ज़्यादा overhead.
नहीं, ओवरहेड का यहाँ पे बात नहीं है. Why can't we perform at the router? See, why can't we perform here at the intermediate device? Because first of all the fragments, because if you say that this is the assembly point, right? Then just now you said in a datagram approach, fragments may take any path to reach the destination. Just now we discussed that, and that is what the concept of datagram approach. So in case if I say that the assembly will be here at this node, so that means I am putting a condition that all the fragments must pass through this router, right? So now once all the fragments, it is necessary to pass through this router, so that means what? It violates. ये किस तरह की रूटिंग हो गई? अगर मैंने बोला कि आपको यहीं से जाना है, तो what kind of routing it is? हाँ?
Dynamic.
ना, ये तो फिक्स रूटिंग हो गई ना. Because if I am saying that all the fragments must pass through this router, right? So means I have fixed the path that you have to pass through this in order to reach the destination. All the fragments must pass through this router. So that means I have fixed the path. So that means it violates the concept of dynamic routing. Second is at the router, at the intermediate device, the buffer space is also an issue. Because there may not be sufficient buffer at the router, right, to hold all the fragments, right, till the last fragment reaches at the router, right? So seeing these two difficulties in assembling at the intermediate point, at the intermediate station, at the intermediate device, the reassembly is being performed at the destination. I hope it is clear that the why the reassembly should be performed at the destination, not at any intermediate device, because if I say at the intermediate device that all the fragments need to pass through this router, will force them, will make the path fixed for all the fragment. So that will be basically a fixed routing. So that violates the concept of dynamic routing, because in the datagram approach, the fragments can take any route to reach the destination, right? So you know that how it is fragmented, because there is a application data, means from the higher layer there is a user data. So that comes over, transport header puts its header, then it passes to the network layer puts its header. So up to this it is encapsulated, right? There are two types of approaches: connection control, connectionless, and connection oriented. So you have already studied these things. Connectionless, PDU treated independently, connection oriented, virtual circuit. Datagram approach, virtual circuit. So we prefer connection oriented for a lengthy exchange of data, because once the connection is established, because there is a lot of overhead in connection establishment. So once the connection is established, we want that the data should be exchanged for a longer period of time, because connection oriented approach has many advantages, because there is no chance of losing packets. All the packets will be sequenced and will be delivered in sequence. Okay, no packet will be out of order. So basically, in a connection establishment, in a connection oriented way, there are three approaches. Okay, three phases: connection establishment, data transfer, connection termination. So you know that first the two party which is ready to open a connection, so it sends a connection request, and if the connection is accepted based on the other party is ready to accept the request, it will be accepted and data transfer will take place. Data packets will be acknowledged, and whenever any party wants to terminate the connection, they can terminate the connection by sending the terminate connection request, terminate connection accept. I told you that this connection termination can be an abrupt termination or a gradual termination. In abrupt termination, we lose the data. In gradual termination, that whatever data is present in the network, that is first collected and then the connection is being terminated. So while connection establishment, there are many things that when the two parties opens up a connection, like when you want to do a friendship with the other, you ask that what are your hobbies and other things. And similarly here also, when the two stations wants to open a connection, they want to know about each other, that what is the maximum packet size they can handle. They can negotiate some parameters, that what will be the syntax, semantics, timing. Okay, they can handle optional features, right? So they can discuss maximum packet size, all those things they can negotiate before the connection is through, right? Data transfer and termination, as you have seen already, that the data is being transferred in the form of PDUs, and depending on the type of protocol, generally in connection establishment, if it is a reliable network, okay, all the packets, all the PDUs will be delivered. It provides flow control, error control, right? So it is just like acknowledgements will be there. Sequencing is an important thing, that's like you have seen in SDLC. I just now told that as far as the connection oriented protocols are concerned, which uses sequencing like SDLC. So in that, PDUs are numbered sequentially. Okay, each site keeps a track record of outgoing and incoming numbers. So you remember 0, NS, NS, NR, right? So you must be knowing that information frame, NS, NR, sequence number of a frames, transmitted frame, received frame, right? So it supports three main functions: order delivery, sequencing helps in order delivery, flow control, error control. Can you say how the sequencing helps in flow control and error control? You have seen now that you have studied different flow control schemes, stop and wait, sliding window protocol, right? So you see all the both the sites keeps the sequence number of the packets, and then based on that which of the packet sequence are acknowledged, which are not yet to be acknowledged. Okay, so for that sequencing is important. And similarly in error control also. Can you say any error control scheme? And it is also not necessary that it will be available in all connection oriented protocols. See, what is order delivery? That as first of all, I told you that if the PDUs arrive out of order, there will be an issue in the assembly. Then there are different issues, other issues also, that uh, if the PDUs may arrive out of order, they may arrive from a previous connection if you are using the same sequence number. So sequence number should be chosen in a proper way, right? Like I have shown you an example here that A and B are communicating, it is sending the frame with sequence number 1, 2, 3, 4, right? But somehow this sequence number 1 didn't reach, okay? It didn't reach. And because there is a cumulative acknowledgement that a party can use, okay, so after the 4 frames were transmitted, it sends a reject one, because depending on the window size, this side is allowed to send that many frames, right? So once it sends the 4 frames with sequence number 1 to 4, then it sends a reject one, right? So by the time this reject one reaches at A, some other from some other connection, okay, this sequence number 1 appears over here. So this one will be considered as a valid sequence number 1 by the station B, and once A sends a frame with sequence number 1, it gets rejected by B. So this kind of scenarios may happen, right? So if you are using the same sequence number in the lifetime of a frame, okay, so the sequence number space should be very large enough. So we will see all those things, okay, that what should be the sequence number field, and how what should be the size of a sequence number, so that it should not be repeated, okay, in the lifetime of a packet, in the lifetime of a frame. So you know that you have studied different flow control schemes, stop and wait, credit, okay, uh, because in credit scheme is used many places, like uh, where a credit is to be given, just like we use a credit card, right? So based on the credit given by the bank, we can do purchase. Okay, and once we repay the credit, once again more money is credited to our account. Similar way, the credit scheme where the receiver grants a credit to the source. Okay, and based on the credit given, that many frames a source is allowed to send without acknowledgement. So all these things you have already studied. Error control, error correction code. Okay, like if any error occurs in the frame, how will it, how the receiver will check. Okay, so CRC, all those things you have already studied. So you can see that the addressing, so you can see already I have told you that at the TCP, it is called as a port number, because TCP is an end-to-end logical connection. It provides error and flow control. So multiple processes are running at the end user. Okay, so these processes are identified by the port numbers. So it is called as a socket address, which is a combination of the IP address by which this host will be identified, and on this host multiple processes are running. Each process will be identified by a port number, right? So these points are called as service access point, which provides services to the upper layer. So application layer extract the services of TCP, right? And this is a router. Router checks the IP address, right, and find out the network access protocol. Okay, this is one network. This is another network, which is through which this is physically connected. All these things. So it checks the network address, okay, physical address, and then network access protocol passes to the host B, right? So they all check the IP address. Network access protocol is nothing but your MAC protocols. Okay, they are nothing. Network access protocols are nothing but your MAC protocols. So addressing modes, I told you earlier that there will be, it can be multicasting, it can be broadcasting, it can be, broadcasting is not allowed in IP, internet. It can be multiple unicast, it can be multicasting, right? So there are different ways of addressing modes. Multiple similar connections can be clubbed together, multiplexed together, right? Uh, so that is called multiplexing. That you have studied two types of multiplexing earlier. That is called as an upward multiplexing and downward multiplexing. I think you have studied in the datacom, right? So the same thing, multiplexing, like many connections will be combined together and transmitted on a single channel. The downward multiplexing on upward multiplexing, right? Inward or upward, downward and upward multiplexing. So all those things you have already studied, right, in the previous semester. So I am not discussing that. Upward का मतलब होता है when the lower level, like multiple higher level connections share single lower level connection, right? So that is called as an upward multiplexing. And downward multiplexing where higher level connections built up on top of multiple lower level connections. Okay, so So that is the difference in upward and downward multiplexing. So transmission services, like I told you that there are various transmission services that when we talk about internet protocol doesn't provide any kind of a priority, right? Because it works on a connectionless basis. So there is no priority scheme provided that this one should be preferred. Generally होता क्या है कि there should be some priority, na? That generally in our surroundings also we see that everyone has some priority. You also have some priority that I will do this job first, then this job first, then this job last. Similarly, if I say about application wise, different applications have different priority labels. Because some of the applications, if I say about real-time applications, they are time sensitive. So such packets which are from those applications must be given some priority, higher priority as compared to traffic which is time insensitive, right? So priority should be there, priority should be provided, right? We have seen the in the token ring priority scheme, right? What is quality of service? Quality of service has different parameters. See, internet provides the best effort service. Internet, or I should say IP provides the best effort service. See, the meaning of best effort service is, see, whatever resources will be available in the network, you can use them. So that will be the best effort service. Okay, nothing more will be provided, right? But what is the meaning of quality of service? Quality of service means like, see, as in today's world, everyone is having like everybody wants that they should be they should have some kind of privileges, right? So similarly, in the networking also, like multiple applications are there. Each application may be different from the other application's requirement, right? So some application one, suppose application one wants minimum throughput, because for that particular application throughput is not at all a concern, right? Even with less throughput also it will work fine. So for that minimum throughput is required, but it wants that the delay should be minimum. The network delay should be minimum, right? Application 2 is just opposite to that. It wants the maximum throughput. Whatever be the delay in the network, it doesn't bother, right? Similarly, some application wants that I want that no packet drop, right? No packet drop. So they application state, different applications state their requirement, right? And providing them over the same internet, which eventually provides only the best effort service, is called as the quality of service. Like these are the quality of service. There are different parameters can come: minimum delay, minimum cost, minimum throughput, maximum reliability, okay, minimum delay, okay. So these like minimum packet, no packet loss, right? So there can be a maximum many parameters that can come. No router processing delay, right? So there can be a possibility of many parameters that an application can state. So now there are provisions. We have quality of service models. There are provisions that application can state their requirement in advance. Okay, जैसे हम कहीं जाते हैं, whenever you go somewhere, you want to visit some other place, you go, you book a train, you reserve a seat in a train or a plane, and then you proceed for your journey. Similarly here also, and if you are not getting, suppose you want to travel in AC second class, and if you are not getting that AC second class, okay, sometimes you get AC third class, sometimes you get sleeper, sometimes you do not get, and if you are not getting, you may have to travel in a general class, right? That is also a possibility. So similarly here also the resources are there in the network. The application has to reserve the resources. So if resources are available, they will be allocated to the application in advance. So there is a resource reservation protocol, okay, that keeps track of all the resources, and if the resources are available, they will be allocated to the applications, and if the resources are not free, then an application will be provided a best effort service, right? Then similarly security is also a concern, because as you can see that routing data just like that in any part of the network is not safe. Some portion of the network may not be safe for some critical data, right? So to safeguard our data, right, in such networks is also a challenge. So we require some mechanism, okay, to protect our data, right, from eavesdropping, or to see that by some kind of authentication, by some kind of encryption techniques, right? So we need some kind of security also. Okay. Okay, so can you say today are we having quiz today or tomorrow? Because I didn't announce, that is why I am saying that, so that nobody should say that I didn't, I was not knowing. So means I have not written it, though I assigned it, I announced it in the class. कैसा आप लोग बोलो? बोलो बोलो, आज ही है ना फिर क्विज? अगर तुम कुछ नहीं बोलोगे,
आज ही रख लेते हैं सर, शाम में 6 बजे।
ठीक है ठीक है। There will be 20 questions, okay? There will be 20 questions, 0.5 marks each, okay? Okay, yes, then sir. Thank you. Time will be 15 to 20 minutes. ठीक है, न्यूमेरिकल नहीं होगा ना कोई, तो टाइम का जरूरत नहीं है। ओके, यस।